Hello everyone. In this video we are going to discuss about the demineralization process, also called as ion exchange process, also called as de-ionization process for treatment of water. So this is one of the methods which is used for external treatments of water to convert hard water into soft water. So in previous session we had seen the zeolite process for softening of water. However, it had few disadvantages. So those disadvantages which were there in zeolite process are overcome in the ion exchange process. Let's have a look at the principle first. So in this process, when water containing cation and anion impurities is passed through the resins, cation exchange resin captures all the cations and anion exchanger resin captures all anions to give pure and all ion free water. So in zeolite process, we were using a zeolite bed which is hydrated sodium aluminosilicate as a softener. So when water was passing through the zeolite bed, the ion exchange was taking place. So in this method, we are using ion exchange resins. So what are ion exchange resins? Those are basically polymers. So they have a base of polymer and they have exchange sites. So these are insoluble polymers in which the base is made up of a polymer, and at the side chains they have exchange sites. These are called as ion exchange resins. So there are two types of resins which we are going to use in this process. One is called as the anion exchange resin and another is called as the cation exchange resin. So as the name suggests, anion exchange resin is going to exchange all the anions present in water, means all the negatively charged ions present in water, and cation exchange resins are going to exchange all the positively charged ions which are present in water. So water is hard basically due to presence of salts of heavy metal ions, mainly calcium and magnesium. So anion and cation exchange resin will exchange those ions present in water with OH minus ion and H plus ion, resulting into formation of a pure or a softened water. So you can see the structure of anion exchange resin here and cation exchange resin. The structure is similar. It is having a backbone of a polymer. So this is the polystyrene group. So it is having a backbone of a polystyrene group, and at the side chains you can see exchange groups are present. So if it is anion exchange resin, here there is a presence of tetramethyl ammonium group, ammonium hydroxyl group. So there is a quaternary ammonium group present at the exchange site of anion exchange resin. It has loosely held OH minus ions. So this anion exchange resin will exchange all the anions, negatively charged ions present in water with its hydroxyl group. Whereas in cation exchange resin, the backbone is again of the polystyrene group. Here the backbone is again of the polystyrene group, but at the side chains it is having a sulfonic acid group which is having H plus ion, which will be exchanged with the cations, positively charged ions present in water, with its H plus ion. So here either it can be a sulfonic acid group or a carboxylic acid group. So anion exchange resin is going to exchange the anions with its hydroxyl ion group, while cation exchange resin is going to replace the cations present in water with the hydronium ion group, that is H plus group. Let's have a look at the process for better understanding. So this is the process of ion exchange. So in this method, you can see there are two containers. One, in the first container, a cation exchanger is present, and in the second container, anion exchanger is present. So cation exchanger means here it will contain the cation exchange resin, and anion exchanger means here it will contain the anion exchange resin in the container. So first, as the raw water enters from the top, it will first pass through the cation exchanger, where all the cations present in the water will be replaced by the H plus ions in the cation exchanger. So this acidic water, since the quantity of H plus ions is going to increase in this water, we can also call it as acidic water. It will then pass into anion exchanger, and here all the anions present in water will be exchanged by the OH minus group, hydroxyl group present in the anion exchanger. So that H plus and OH minus will react to form a pure water. So this, it will then pass through a degasifier. So this is a degasifier where the dissolved gases like carbon dioxide will be removed from water, and we will get ion free, or we can say a pure water. So this is the process of deionization of water, also called as ion exchange process. Now, after using, there will be a time when all the H plus ions present in the cation exchanger would be exhausted. There will be no more H plus ions available for the exchange process to take place. Similarly, the OH minus ions which are present in anion exchange, they will also be exhausted. So during that time, we need to regenerate those ions. So the regeneration is done by using acid for cation exchanger and by using an alkaline solution for anion exchanger. So cation exchanger is regenerated by using a strong acid, while anion exchanger is regenerated by using a strong base. Let's have a look at the reactions. So what are the reactions of cation exchange and anion exchange? So in cation exchange process, H plus is the ion which is present in the cation exchange resin. R is used to denote the resin, the polymer group. It will react with the cations present in water. When water will pass through the cation exchanger, then the cations present in water will take place of the H plus ions in the resin, and H plus ion will go into the water. So this is the exchange reaction. Similarly, this acid plus water will then pass through the anion exchanger. Here all the anions present in water, like here it is chloride, will be exchanged with the hydroxyl group present in the resin. So this is the reaction. The chloride will take place position in the resin, and this OH group would be given out in the water. So this H plus and this OH minus will then react to form a pure or a ion free water. Similarly, the reaction can be given for calcium ion. So same reaction is written. The calcium ion will take place in the resin while H plus will come in the water. If there is a sulfate ion, then the reaction will go as shown here, that the sulfate ion will take its position, its place in the resin, and hydroxyl ion will be given out. So this is the exchange reaction. Now the regeneration reaction. So cation exchanger is regenerated by using a strong acid like HCl. So exchange reaction has taken place. So in the resin, we are having the sodium group, as you can see in the first reaction. So when we pass a strong acid through the exchanger, again the resin will have H plus ions and NaCl would be formed. Means the Na ion will be given out in the water. Similarly, the anion exchanger, here we can see in anion exchanger, Cl has taken the place of hydroxyl ion. So we pass a strong base, which is sodium hydroxide. So the reaction will take place and a resin will be regenerated. So hydroxide ion will again take its position in the resin and NaCl would be given out. Similar reaction can be written for calcium and sulfate as well. So these are the regeneration reactions. So this is the complete process of ion exchange. You can see, as compared to the zeolite process, this process is little complicated, and so the operational cost is also higher, because in this case we are using strong acids and strong base for regeneration, while in zeolite process we were using a brine solution. However, the water which we are getting in de-ionization process, it is much more pure than what we were getting in the zeolite process. In zeolite process, all the sodium ions were going into the water. So it wasn't a pure water as compared to this water which we are getting in the ion exchange process. So I hope you understood the ion exchange process here. If you have any doubts, you can just put it in the comment. And if you are liking my videos, kindly do subscribe, like and share. Thank you.